This video was made possible by Brilliant. Start achieving your learning goals for 20% off by being one of the first 200 to sign up at brilliant.org/RealLifeLore. Light is about the fastest thing that you can possibly imagine. Think about how fast it seems when you turn on a light switch in your room and you see it instantly fill up with light. Or when you shine a flashlight on something and the light immediately appears on whatever you're shining it at. It feels instant because at our scale, light moves so quickly that it might as well be. But when you move out beyond our scale, light gets slower and slower to the point where it quickly seems to more resemble a snail rather than, light speed. Here's what I mean. Light on Earth seems really fast because Earth is small. Light travels at a speed of 299,792,458 meters per second when in a vacuum, which is fast enough to completely orbit the entire Earth more than 7 times in a single second, which looks like this while it's happening. When you flip on a light inside of your room, the light probably moves fast enough to reach across the entire room in just 1/500,000th of a second, which to mere human eyes basically feels instant. This is why instant communication on the internet between any two people on the Earth's surface is possible, because Earth is a small enough place where light speed basically does mean the same thing as instant. But that all changes drastically when we zoom out just a little far away from the Earth and get out into the rest of the universe. Far from being instantaneous, it takes light 1.255 seconds to cover the distance between Earth and the Moon, which has all kinds of weird implications. When the Apollo astronauts were there was a lag in communication between them and Mission Control back on Earth, because a message from Mission Control would take 1.255 seconds to arrive, and then the astronauts' message would take 1.255 more seconds to come back, for a total message relay time of 2.6 seconds round trip. So in the future, when you're trying to communicate on Facebook or Discord or whatever it is with someone living on the moon, you'll have to wait at least 2.6 seconds after sending a message to them before you'd actually get a response, and it's all because of the limitations in speed of light speed communication. But communicating with somebody on the moon is still easy when compared with somewhere else, like, say, on Mars, which is a lot further away from us than the moon is. In the future, when we have colonies with thousands or even millions of people living on Mars, the sheer distance away that Mars is going to create lots of weird and interesting communication problems. Since Earth and Mars have different orbits around the sun, Mars varies pretty drastically in her distance away from Earth. On the close end, it takes light just over 3 minutes to cover the distance, which isn't bad, but on the far end, it'll take 22 minutes and 24 seconds, which makes instant communication impossible. If you have a friend who lives on Mars and you send them a message when Mars is furthest away from Earth, your message will take over 22 minutes just to get there. And then whenever they get around to responding to you, it'll take over 22 more minutes just to get back to you. Even if your friend on Mars responds immediately when they get your message, it'll take about 45 minutes after you sent it before you get a response. And that's the quickest response time possible, so nobody should really get upset after not getting replied to for a while by a Martian. This is going to become a big problem in the future, and I suspect it's going to cause human civilization on Mars to gradually feel more and more isolated and separated from Earth. But light just keeps getting slower and slower the further we move away from Earth. The time it takes light to reach Jupiter from Earth is anywhere between 33 to 53 minutes, meaning that when NASA has a probe in orbit, they have to wait for around 2 hours sometimes just to process information and send instructions to correct a potential navigation error, meaning that light speed instructions are sometimes too slow to arrive in time to fix the problem. Even light from the sun takes a while to reach us here on Earth, generally around 8 minutes on average, which looks like this in real time. It's so slow. So slow, in fact, that if the sun all of a sudden just disappeared for whatever reason, we wouldn't even realize it back here on Earth until 8 minutes after it happened. And just forget about trying to maintain instant communication at the outer reaches of the solar system on Pluto, because it takes light over 5 hours to get here from Earth. And keep in mind, everything that we've talked about so far is just within the confines of our own solar system, so light gets even slower when we get even further out. The nearest other star to our sun, Proxima Centauri, is 4.24 light years away from the Earth, meaning, yeah, it would take 4.24 years for light from Earth to reach it. So just imagine what it would be like if we ever successfully managed to get colonists or a probe out on a planet there. A single message between the colony and Earth would take almost a decade to achieve, because the light speed message would take 4.24 years each way going back and forth. To truly appreciate how insane that is, if there were a human colony on a planet there right now, they would only just now be hearing about news and memes from 2015. Do you even remember what was going on back then? Boeing had just unveiled the 737 MAX. Obama was still the US president. Brexit hadn't been voted on yet. Everybody's favorite educational YouTube channel hadn't even been created yet, and people were arguing over what color that stupid dress was. It's blue and black, it just is. So this would be the current state of our planet that would be reaching the residence of Proxima Centauri b. In the future, it'll take 8.5 years just to get a response from somebody there after you send them a message. If humanity's life expectancy remains around 80 years in the future, you'll only be able to share a maximum of 9 messages in your entire lifetime with somebody who lives around Proxima Centauri b. And that's what the fastest form of light speed communication looks like with just the closest star to us in the universe, let alone the billions and trillions of stars and planets that exist even further away from that. The speed of light is slower than you think it is, and it's too slow for our grander ambitions in space. We just haven't really developed to the point yet where it's become a major problem for us, but it will happen eventually, and we need to be prepared for it. The physics of light are complicated, but even though light moves slowly, there's all kinds of things that you can learn by looking at it. You can use the principle of parallax to learn how far away a star is, or you can look at a star's luminosity to figure out how hot it is. And you can learn how to do both of these things and so much more right now in the astronomy course that's offered over at Brilliant. It's never too early or too late in life to learn something new, and what makes Brilliant so special is that they help you learn the kinds of things that you were forced to and maybe struggled with when you were a kid. Physics, calculus, computer science, algebra, and more, but they actually make it fun and approachable. The feeling of achievement when you finally understand something inconceivably complicated is amazing, and Brilliant's teaching style of breaking down big, scary concepts into their smaller, more intuitive chunks makes that possible to experience for everyone. You can even do this on the go with their app. And if you're the type of person without a lot of free time, but who still wants to learn new things, you can set a goal to do each of their daily challenges in those small free moments that you get. Best of all, if you're one of the first 200 people to sign up by clicking the link in the description or by going to brilliant.org/RealLifeLore, you'll even get 20% off. And as always, thank you for watching.